One. You ready?
Yep.
This is Jeff Mucci with RCR Wireless News, and we are here with Iain Gillott with iGR. Iain, thanks for joining us today.
No problem. Good to see you.
Well, you had your annual DAS forecast press release last week, and I couldn't resist but to give you a call and talk a little bit more about it. $19 billion in the U.S. Tell us a bit about the study, how it was prepared, and then we'll go into some more detail about DAS.
No, I think this is the third or fourth year we've done this now, basically, simply, we went out there and looked at how much DAS is out there. One of the big challenges we have every year is how many DAS systems there are, physical systems installed, and nodes and those types of things, as well as how many carriers are on those systems. So if you go to all the carriers and say, how many DAS do you support, you get a huge number because, of course, multiple carriers are on the same DAS system. They plug into the same DAS. So the report does break that out. This year we also looked at MDUs, and we do look at how the carrier is also connecting in, look at the costs of deployment and how much is being spent, and hence the 19 billion you mentioned.
So does what constitutes DAS in your study? Does it include ODAS or is it simply iDAS?
It's both. So it is literally DAS.
Okay.
And this is one question we always get is where does it fit compared to a small cell? To us, in our hierarchy, DAS is a small cell. So just as a femtocell, picocell, metrocell, etc., remote radio head is as well. So DAS is one of those variants, and we do break out the other ones as well in different reports. What's changed this year as well is previously, this has changed over the last couple of years, but now we're seeing a lot more deployments where you take actually a small cell radio and plug it straight into a 2-watt or 5-watt unit, plug it straight into the DAS array. So you don't need the attenuation board and all the things that you need when you take a 40-watt macro cell and try to power it down. And that saves money. That makes it a lot cheaper to deploy. So.
Well, you mentioned small cell, but your report also mentions digital radio systems, DRS.
Yeah. So
expand a little bit on what a DRS system is and how it compares to DAS and small cell.
Yeah, so we look at that as a form of DAS. It is a distributed radio system instead of antenna system, and it really basically what you're doing is put little radios out on the end of the fiber and controlling them digitally. So you can be a little smarter about it in terms of where that capacity goes. You can deal with interference and things like this a little better. So we really look at that as a form of DAS. It is still distributed. So you've distributed the radio throughout a building, just as you do with a DAS. And actually, this is one of the things we've been talking about publicly. I've mentioned it in conferences. Is DAS is one of those technologies. It really needs a new acronym. Distributed antenna system sounds a little 2G, 3G. We need to get a little more digital in there, a little more radio distributed. Maybe it should be digital distributed, broadcast system. I don't know.
Well, this year, 2016 appears to be a year more small cell deployments. So I'm kind of curious how the small cell deployments and densification efforts are impacted the DAS specific forecast.
Yeah, so you're right. It is interesting, and there's two things really we've seen happen. The first is that it's very difficult to get a lot of small cell outdoor deployments. Not because of the technology, but because of the zoning and the permitting and the right-of-way and all these things. As that happened, a lot of those vendors and that opportunities kind of run inside and said, well, we can cover the buildings. And then with buildings, all you got to deal with is a property manager or a property owner and the carrier. So you're not dealing with right-of-way and cities and municipalities and things like this. So we have seen a lot more interest in small cell indoors. DAS has, of course, always been indoors as well as in arenas and things like this. What we've seen in the forecast now is the arenas are pretty much done. I mean, there's not many football stadiums out there that don't have DAS in some form or another. Same for the convention centres. So now, as I mentioned earlier, getting the cost structure down on those DAS systems with things like DRS and using the small cell architecture, then DAS can start to address smaller sized buildings. And so what you end up is almost like a top down and bottom up. If the femto cells are dealing with the home and the small small business, the DAS is dealt with the big buildings, the kind of meeting in the middle, if you like. And that's what we kind of see happening. I'm not going to tell you that DAS can do every size of building. It doesn't. It's not economic at small buildings. And likewise, putting 100 femtocells into a large building doesn't make any sense either. So, but it's kind of matching the technology to the opportunity here is what's really happening.
So you mentioned technology changes are driving down the cost curve. Can you be a little more specific in terms of how technology is changing that ecosystem cost structure?
Well, so two things. One is like that DRS you mentioned. If I can be smarter about where the radio signal actually goes in the building and control it at the node, I can be much more efficient in how I plan that and deploy that building. Okay, and then the second thing is I mentioned that you plug a small cell into the antenna array. You don't need that attenuation board. Those attenuation boards are $10,000. And of course, a macro cell is can be tens of thousands of dollars. Yeah. So instead, we're plugging in a $3,000-$5,000 unit into something that used to cost $50,000. Immediately, you've got a cost savings.
Got it.
And obviously, it's easier.
Well, earlier this year, we visited Verizon in New York City, and they were in the process of building out these base station hotels that, in their mind, were going to serve indoor DAS, small cell radios, etc. How much of an impact is using a base station hotel to serve an in-building DAS versus building a head-end in a building? What kind of impact will that have on the cost structure?
A little. It depends. I mean, actually, the building, if we've got a large building and you're putting the radio for the DAS in the basement, you may want to choose to put your data center down there to feed the rest of the remote radio heads outside of that building. It may be the center. So on the DAS, doesn't have any difference on that. Likewise, it could be the building over. And it's a tough question to answer because it really depends on what the connectivity is available into that building. If we're going to put that head end somewhere else, we've got to have really good fiber going into that from one building to another. So if it's not there, it makes no economic sense to install the fiber. I'll tell you, we're not digging up streets for this. So there's no reason that actually the building with DAS could not be the focal point of your that solution you're talking about, where we push remote radio heads outside.
Well, as you move away from the stadiums and hospitality and convention centers down to the MDUs and the commercial buildings, who's in a better position, the carriers with the building owners or the traditional neutral host providers?
Yeah.
Next question.
Well, the answer is yes. And actually what we've seen is it really depends on the building owner. And I was talking to one of the big vendors who's moving into a new headquarters building. And the whole thing is wireless. And I said to them, so who built the DAS and the architecture for the building? Was it you or was it the building owner? I mean, you're the tenant, they're the building owner. Who's driving who? Did they offer it to you or did you demand it? And it seems to be that some building owners are kind of thinking ahead of the curve and starting to get involved in this. Others are finding that tenants are coming to them saying, hey, I'm sorry, but if I'm going to take that floor or that building, I need this, this, and this. And it is power, AC, parking, and wireless service. In others, the carriers are forcing, so it depends on the relationships that they've got, but they've got a lot of building relationships already. I mean, if you think of the LECs, who are also wireless carriers, they've got all these relationships already in some cases. So it really depends on who you're talking about and where, but it seems that, and then there's the third parties going, hang on, we see an opportunity here. I'm going to go get some relationships with property owners. I'm going to bring the carrier and a DAS vendor to them, and I'm going to be the systems integrator, if you like. And we're seeing all of that right now. And I think it's a little too early to say which model is going to win. Right now, we want those models executing. We want the systems being built.
Well, it seems to me over the past 4 to 5 years that the building asset managers, whether it be a commercial building or an MDU, the asset managers really didn't connect the dots in terms of vacancy rates caused by lack of coverage translates to millions and billions of dollars worth of overall value in their portfolio. Are you starting to see a change?
Yeah, there's certainly at the high end. I'm not sure we're down at the level where there's a building manager who's got 4 or 5 buildings, let's say, but certainly the people who own millions of square feet, that absolutely this is the next big thing we're going to have to differentiate on, just like power, AC, etc. So it'll definitely get there. I think it will be a trickle down.
Yeah.
But you're right, the asset managers, I mean, if you think about it, they're already in that direction anyway. There's a number of companies that now have bring your own device. Well, you can't have bring your own device be effective if there's no coverage in the building.
Yeah.
So the asset manager at the company has to say, bring your own device because we have got wireless. I've made sure of that. I've done my job. Bit of a problem if there's no coverage there.
Yeah. Well, I want to close on Siberry. I've talked to some OEMs who say Siberry is the future, and I've talked to other OEMs who don't have a Siberry product who say Siberry is going to get passed by. You're the expert on DAS, and so I'm kind of curious what your thoughts are on Siberry.
Yeah, Siberry is going to evolve. And today's Siberry there is a new version, I think it's version 6. And there's another acronym for it, which of course I know you're going to ask me now, I can't remember. But basically, Siberry today, there is a radio and then there's the baseband, and Siberry runs between the two. What we're looking at doing is taking that baseband and splitting that functionality. So some of that baseband functionality goes on the radio, so we've got a little bit more flexibility in architecture out there. And other parts of that baseband get pulled back into a data center. And then let's call it Siberry 6 actually manages between the two. The problem with Siberry today is the overhead on it is big. It takes a chunk of bandwidth to run it effectively. And it's okay when you're running a few remote radio heads, but when we're talking about 100,000 or so, it gets really, and remember today, we do have remote radio head, but the radio is on the tower and there's a couple of 100 feet of fiber down to Siberry at the bottom of the baseband. That's fine. What we're talking about now is moving that 15 miles.
Yeah.
Right? That's when the issue comes up. So is Siberry dead? Current version probably isn't going to do what we need it to do. It won't scale. Does the core technology evolve into a new version, just as 3G, 2G became 3G, 3G became 4G LTE? It's the same thing.
Yeah.
So that's what talking about. And you're right, vendors do. Some vendors say, no, Siberry's dead because we've got X. Others are saying, no, Siberry's great because we do Siberry. And they're all actually talking about evolving it to Siberry 6.
So what's your big prediction? I know 19 billion is a big number, but what are some of the other big predictions Iain Gillott has for 2016?
I think, so yes, more small cells. I think you just got to be very flexible in how you define small cell. It really is a lot more difficult than the industry expected. To put these things out there because of non-technical issues. It really is availability of backhaul, availability of right-of-way, etc. So I think you're going to see a lot of remote radio head. My fear is with 16 is that as we talk more and more and more of 5G, that the carriers, and now we're already seeing this, they're kind of reluctant to invest in anything that doesn't have a roadmap into 5G. 5G is close enough now, 2018-19 here, we'll be starting to really get serious about it. I don't want to put anything in 2016 that doesn't have a roadmap to that. So I've got to be very careful. If I'd done that in 2013 or 14, I could have had a 3, 4, 5 year lifespan of that equipment. That's okay. Now I don't have that. So we're kind of squeezing the time frames here. I think that's the first thing. The second thing is we're going to be talking about bandwidth constraints a whole lot more in 16. We know it's bad today. Video is all over the place. You've got AT&T with DirecTV. You've got T-Mobile with their, not counting your gigabytes, in the video
Right.
bucket plan, whatever it's called, and you've got Verizon with Go 90, and all of them at the infancy right now of what we're seeing. But some of the numbers out of T-Mobile make me believe that this is going to be huge. And when I look at my kids, who, you and I are too old, we're not the future, right? My kids are what's killing the network. To them, if Wi-Fi is too slow, my son's in college, it's too slow, he just turns it off and use LTE. And he'll run that, he can use 20 gigs in a month with watching TV. And, complete aside here, I called my cable operator today to get my bill down. I'm actually removing the set-top boxes from my house tomorrow, and we are going to apps over our smart TV. It's going to save me $20 a month.
There you go.
The cable operator told me to do that, and they pushed me and said, use the wireless network, use LTE, watch it while you're out of your house. This is the cable guys. So I think next year we're going to be talking about bandwidth, signaling constraints, capacity issues, and everybody's going to be scrambling. From that discussion, it's going to move into the small cells, remote radio heads, spectrum, who has what, who can get deployed what, who can deal with who to get spectrum they may own. All of that stuff is going to be a big discussion. But the end result of it all is 5G is looming, and I'm not going to do anything that doesn't give me a roadmap.
Well, on our next discussion, we're going to put you on the spot and ask you to tell us what 5G is, but I'm not going to do that today unless you want to volunteer.
Actually, we've just done a report, and IMT 2020, as far as I'm concerned, that is 5G, and that is 2020. That is the technical standard. I never underestimate the ability of the wireless industry to shoot itself in the foot. And 2020, and I think it'd be a brave operator actually who says we are not going to go for 5G. We're going to do something, super fast wireless service.
I just skip straight to 10G.
Well, actually, it's funny because when we wrote the report internally, the joke was that by the time the industry deploys IMT 2020 5G, it will be branded 7G. Facetiousness aside, it probably won't be that far apart from that.
Probably true. Well, listen, Iain, thanks for your time today. I enjoy your holiday, and I'm sure we'll see you at the trade show soon.
You too. See you in the new year. Thanks.